Okay guys, just a little lesson on the area of a trapezium. So this is another one of our polygons from measurement. And it's going to be looking at how we can derive a formula to calculate the area of this shape. So we could break it down into a rectangle and two triangles, and I could prove that formula algebraically, but I wanted to take a wee bit more of a different approach. So the first thing we're going to want to do is we're just going to want to define the sides. So a trapezium has two parallel sides of different lengths, and then we've just got I'm just going to call them random, but they're just two lines connect those two parallel sides. So what you can actually have is you can actually have a right angled trapezium. So that would look something like this here. I'm just going to draw it kind of roughly. You can actually have a right angled trapezium. So this is actually a trapezium as well. It's got two parallel sides and it's got two right angles, and then we just have a line that joins this two various lengths together. So ask yourself, can you have one right angle in a trapezium? You guys can maybe answer that in the comments below, but we'll just label this side here A and this side here B. So how are we going to calculate the area of this thing? So we're calling this A and alongside B, and I'm going to use a pretty similar technique to calculating the area of this thing from a previous lesson, where I'm going to copy and paste that trapezium. So I've just copied and pasted. So we're going to have A and B, and I've written those upside down for a special reason. If I take this thing and I just flip it and put it right next to this one here, what shape have I just created? Hopefully it's obvious. Once it's flattened down, it's a little bit more obvious, but I've just created a parallelogram. And you know that the area of a parallelogram is the height, so the vertical height multiplied by the length. And notice that these are the same length now. They're A plus B. So that's A plus B. So the area of this thing, the area is equal to is equal to A plus B times the height. That is the total area. But if I just want one of those areas, right, I just have to half it. So the area of a trapezium is equal to a half A plus B times H. So if we were to calculate the area of this thing, let's say it was 8, 5, and it has a height of, now remember it has to be the vertical height, let's say it has a height of 4, then all we have to do is plug those things in. So area is a half A plus B, so the two parallel sides added together, 5 and 8, of, write out the full working, a half of 5 plus 8 times, I don't really need a multiplication, but I'll put it there just so it's obvious, 4. Well, that's going to be 2 times 13, 26 units squared. So that is our formula, and we can write this in various ways. Sometimes you might see it like this. You might see it as that, but it's all the same thing. It's H times A plus B divided by 2, or times by a half. So there is today's record of learning, the trapezium area. And with that, we will, I've got 8 problems I'm going to go through in the next video that will be a compositional area.